Welcome back, and I think this should be one of my last videos. If not, I'll post another video for this lesson on factoring. So we're going to finalize up with sum of cubes, differences of cubes, and group factoring. Sum of cubes. Here is the general rule, and I'm going to write it down over here. If you have two terms that you can cube root, and there is a plus, which is hence called sum, this is how you're going to factor it. It's going to be a plus b on your first factor, and after that a squared minus ab plus b squared, on your second factor here. Okay, a plus b quantity times a squared minus ab plus b squared quantity. All right, so let's apply that rule possibly on 63 and 65. Okay, so on 63, what you want to do is see if they are cube rootable, and they are, so we can get our a and b values. So if we cube root an a cubed, your a value is going to be a. Okay. If you cube root 27, what times what times what is 27? Hopefully it's a 3. Okay. And then I'm just going to write the general formula again one more time right over here, and now we can start putting them in. So it's a good thing a is just a, so I'm just going to go a over here, a squared minus, okay. And then for every b value, we're just going to plug that in for a 3, so it's going to be 3, and 3 will be here. So this is going to be 3a, so I'm going to go 3a, and then this is going to be 3 squared. 3 times 3 is going to be plus 9. This second factor is unfactorable. You're going to have a difficult time. Even I'm going to have a difficult time factoring this. So you're just going to leave it like that, pretty much like this. Hopefully that's the correct answer. Well, let's just take a look at 63. A plus 3. A squared minus 3a plus 9, which is that. Okay. What if the variable, like on 65, is on the second part? That's totally fine, just as long as we have a plus sign and these two are cube rootable. So let's just check that out. So our a value this time, what times what times what is 64. So hopefully it is a 4. 4 times 4 is 16, times 4 is 64. And then your b value, cube root of x cubed, is going to be x. So you are going to write it like this. Okay. So noticing again the structure, so a plus b. So I'm going to be particular. I'm going to write it as 4 plus x. Yes, it's the same thing as x plus 4, and you're not going to get much wrong, but it's just for structure-wise, I'm going to leave it like this. Okay. Now, a squared minus ab plus b squared. Okay. So 4 times 4 is going to be 16. So that is the 4 squared. Okay. Minus a times b. This is going to be 4 times x. So that's going to be 4x. And then plus your b squared is x squared. Okay. So that's going to be plus x squared. Okay, hopefully that's not hopefully that's a little bit simplified for you guys. So that's how you're going to do 63 and 65, and that's how you're going to do the rest of these problems up front. I did put some hints like 68, maybe you should factor out a 3 first, and then you could go and do the sum of cubes. Okay, let's jump on down to 69, differences of cubes. So if these two terms are cube rootable and there's a minus sign, there's a different rule for that. So let me put it up over here. A cubed minus b cubed. This time around it's going to be a minus b for your first factor. And then in the second factor is going to be a squared plus ab plus b squared. Okay. The number that I want to do, I think I said 69. You know what? I want to do number 70 instead. Okay. So let's take a look at number 70. I just want to check if they're cube rootable and there's a minus sign. So our A value, cube root of 27 is 3. Cube root of u cubed is going to be u. It is actually very important this time around to have the structure that's going to be parallel to this. Okay, so a minus b, a squared plus ab plus b squared. We're using this formula because it's a difference of cubes and not sum of cubes like the previous page. So now we're just going to input, and just be careful, it is not u minus 3, it is 3 minus u. So that's what we need to be inputting. There is a stark difference between u minus 3 and 3 minus u. Okay. All right. A squared. So this is going to be 3 squared over here. 3 squared is going to be 9. Plus, okay, a times b. So that's going to be 3 times u. Plus, and then b squared, which is going to be u squared. And then u squared is just going to be over here. So especially when we have some minus signs involved, it's going to make a difference for the placement. Okay. All right. So this is how that's going to be done on this back page over here, 69 to 74. And then 74, I have some hints for you guys over here. Last but not least, let's jump down to this last section of factoring. And I want to call this group factoring. And I'll probably do at least 2 problems for you guys today. 75. Whenever I see 4 terms, then I'm already thinking right away, this is probably going to be group factoring. And this is what I want to do. So I want to check maybe the first 2 terms and 2 last terms and check for a GCF. Okay. All right. The highest number, the greatest common factor for numbers for 36 and 42. Well, I think they can be divided by 6. So I think your GCF over here is going to be 6. And then after that, R, there's 2 R's here, there's 3 R's here. So 6R squared is going to be on this first GCF. We'll call that GCF1. On the second GCF, there's no R's here, there's 1 R here, so we can't take out any variables, but I believe we can take out a 5, I think. Let's do that. Okay. All right, so what's going to happen is the 6R squared is going to be here, and then the plus 5 is going to be here, and then we just got to figure out the leftovers. 36 divided by 6 is 6. You already took out 2 R's, so you're going to have 1 R left over. 42 divided by 6 is 7. And then you already took out all the R's, so there will be no R's left over here. All right. On the last 2 terms, you're taking out a 5. So 30 divided by 5 is 6. And don't forget the R because we didn't take that one out. Then 35 divided by 5 is a positive 7. Okay. All right. You know you did it correctly because when you see that these 2 factors match. When they match, this is how you're going to finalize it. You're going to take these 2 different GCFs and put them together in one factor, 6R squared plus 5. Well, what about the 6R plus 7? You're also going to bring that down, but you're only going to bring that down 1 time only. Okay, 1 time only. And then this is your answer. Again, if you want to check your work, you can do FOIL or box method. 6R squared times 6R is 36R cubed. And then you're going to go your outer, inner, and last. 5 times 7 is 35. 6R squared times 7 is 42R squared, which is over here. And then 5 times 6R is 30R, which is right over here. Okay, so that is 75. I think I want to do one more problem. I know I'm pushing like 10 minutes already. I want to do something like 82. Let's do something like 82, and then that will be the last one. Then you guys have enough information to do this. Sometimes, let's see. Sometimes maybe the best pairing may not be the first two and the last two. You might have to rearrange. So might have to rearrange. What I mean by this is, I'm taking a look at the y's right now. I may want to pair this y with this y, just because they have y's in common. So I think I'm going to put them together and then put these together. So I'm going to rearrange it like this. 9xy minus 21y. Okay. So I'm going to rearrange them, put these two together, and then these two I'm going to put together. And then, since I'm seeing the x cubed a little bit higher in degree, I'm going to put the 12x cubed first and then the minus 28x squared. I actually don't know if this is correct, so I'm just going to see if this works out. Okay, I hope so. If it doesn't work out, then the video is just going to be longer. Okay, GCF for the first one, I think we can take out a 3y. Okay, this is a multiple of 3. This is also a multiple of 3, and they have a y. This doesn't have an x, so I'm not going to take out an x. And then for the second GCF, let's see. Can we divide by 4? Yeah, I think we can take out a 4 and then x squared, because there's at least 2 x's here and there's 3 x's. Okay. Oh, I hope I did it correctly. Let's try it out. 3y. 9 divided by 3 is 3. The y's are already gone, but you're still left with the x, minus 21 divided by 3 is 7. And then that y is gone. Okay. All right. And then we said 4, so I'm going to put the 4x squared here. Okay. 12 divided by 4 is 3. And we took out 2 x's, so you have 1 x left over. 28 divided by 4 is 7, and all the x's are gone already. Okay. And we did it correctly because these match. And so let's finalize this answer. It's going to be 3y plus 4x squared, and then 3x minus 7. And we're only going to write this once, and this is it. All right, you have enough for you guys to do the rest of the problems all the way up to 84.